Why chemistry matters. Think of chemistry as the hidden architect of your day. It turns air into energy in your lungs, browns bread in the toaster, and hardens the glass that lights up your phone. From the color of autumn leaves to the fuel in rockets, chemistry quietly choreographs the matter that shapes our lives. Ancient origins. Long before test tubes, early humans practiced chemistry by mastering fire. Around 7000 BCE they fired clay pots and smelted copper, learning that heat could reshape stone-like ores into useful metal. Egyptians refined the craft, making vivid blue Egyptian faience, fermenting beer, and blending plant resins into medicines and mummification bombs. In China and India, artisans perfected dyes, gunpowder precursors, and steel. Meanwhile, Greek thinkers such as Democritus proposed that everything was built from indivisible atoms, even if they lacked experimental proof. Across these ancient cultures, practical recipes and bold ideas laid chemistry's first foundation, turning raw nature into tailored materials. Alchemy to science. Between the 8th and 17th centuries, chemistry wore the cloak of alchemy. Part mystical quest, part hard-won craft. Arabic scholars like Jabir ibn Hayyan perfected distillation, inventing glassware and discovering strong acids that could dissolve metals. Medieval European alchemists chased the philosopher's stone, yet in the process catalogued alloys, pigments, and new medicines. Swiss physician Paracelsus shifted focus from gold-making to healing, insisting that dose makes the poison. Finally, Robert Boyle broke with secrecy in 1661, demanding open experiments and quantifiable results. Alchemy's furnace had smelted superstition into the first spark of modern chemical science. The Chemical Revolution. In the late 1700s, Antoine Lavoisier shattered the old phlogiston myth by proving that burning and rusting are reactions with a real gas, oxygen. With an analytical balance, he weighed reactants and products to reveal the law of conservation of mass, turning chemistry into a science of numbers. He and his wife Marion coined clear names like sulfuric acid and hydrogen, drafted the first modern list of elements, and emphasized careful measurement over mystical theory. Their work, echoed by contemporaries such as Joseph Priestley and Carl Wilhelm Scheele, ignited a revolution that replaced guesswork with quantitative experiment. Atoms, bonds, and the periodic table. Building on Lavoisier's precision, John Dalton proposed in 1803 that matter is assembled from tiny, unique atoms that combine in fixed ratios. As formulas piled up, chemists asked why elements behaved in patterns. The answer emerged in 1869 when Dmitry Mendeleev arranged known elements by atomic weight and repeating properties, leaving blank spaces for gallium, germanium, and scandium, later discovered exactly where he predicted. Meanwhile, Auguste Kekulé pictured carbon atoms linking into rings, and G. N. Lewis sketched electron dots to explain bonding. By the turn of the century, chemistry had a map, the periodic table, and a toolkit for decoding how atoms join and transform. 20th century breakthroughs. The 1900s unraveled chemistry at the subatomic scale. Quantum pioneers, Bohr, Schrödinger, Heitler, London, showed that electrons occupy quantized shells, explaining the periodic table's logic and predicting new reactions. Synthetic giants followed. Leo Baekeland's Bakelite launched the plastics age. Wallace Carothers' nylon-proved molecules could be engineered like machinery. Radioactivity, unveiled by the Curies and harnessed in the Manhattan Project, opened nuclear energy and medical imaging. Biochemistry leapt ahead with Haber-Bosch ammonia for fertilizers, Fleming's penicillin sparking antibiotics, and Watson and Crick's DNA double helix revealing life's code. By century's end, computers simulated reactions, catalysts cleaned exhaust, and chemistry stood ready to shape the nano and biotech revolutions of today. Chemistry today and tomorrow. Chemistry now engineers matter atom by atom. In nanoscale labs, carbon sheets only an atom thick, graphene, bend electricity and strength in unprecedented ways. CRISPR-Cas tools let chemists edit DNA like text, pointing toward precision cures. Battery researchers designed solid-state electrolytes for safer, longer-range electric cars, while catalysts inspired by leaf enzymes turned sunlight and CO2 into clean fuels. Across the field, green chemistry principles aim to slash waste, swap toxic solvents for water, and recycle plastics back into their monomers. Artificial intelligence robot chemists already predict new molecules overnight, hinting that tomorrow's breakthroughs may arrive faster than we can name them. Everyday impact and closing takeaway. From the aspirin in your cabinet to the OLED pixels on your phone, chemistry silently serves you each day. It heals, feeds, powers, and connects a planet of 8 billion people. Yet its greatest discoveries may still lie ahead. As we confront climate change, disease, and resource limits, the next transformative reaction could come from any curious mind. So keep asking what if? Because every beaker's fizz, every colored flame, is an invitation to explore the hidden logic of the material world.